This is part 2 of the chapter 11 notes. We left off on slide 27. And this slide just explains the differences that men and women have in their iron reserves or their iron stores in their body. And this mostly has to do with men have more stored iron typically than women do. And this is the reason that women often require supplements for iron. If they don't have enough iron, it's called iron deficiency anemia. But it's mostly due to hormonal differences in men and women. Okay, so red blood cell formation is called erythropoiesis, and that is because red blood cells are also called erythrocytes. Red blood cells in adults are formed in the red bone marrow. If you remember, the red bone marrow is found typically in spongy bone. Red blood cell formation or erythropoiesis requires amino acids to form, the proteins, iron and vitamins. Vitamin B12 is important, and vitamin B12 also requires intrinsic factor for the vitamin B12 to be absorbed, and a deficiency in vitamin B12 causes pernicious anemia. Okay, and I'm going to skip this. This is the stages in the formation of blood cells, but I am going to skip this because I want to focus on some other things in this chapter. And remember, we're combining 3 chapters for cardiovascular system. So regulating erythropoiesis or red blood cell formation is stimulated by low tissue oxygen, and that is called hypoxia, low tissue oxygen. The kidney can detect hypoxia can occur in the kidneys, and that can stimulate the kidneys to release EPO or erythropoietin, which is a hormone that stimulates red blood cell formation. And this happens when anemia occurs, when blood flow to the kidney decreases, when the oxygen content of the air in the lungs declines. So like, for example, if you were to be hiking, in the mountains or something like that, when damage to respiratory surfaces occurs. So many different conditions can lead to the stimulation of EPO or erythropoietin. So erythropoietin targets stem cells for red blood cells that are found in the red bone marrow, and it causes the cell division to speed up. It also speeds up maturation of red blood cells. The ones that are immature, it speeds up the maturation of those. Let's see. Okay, checkpoint questions describe hemoglobin. Hemoglobin is found in red blood cells, and it is composed of 4 subunits, and each one of those contains a heme molecule, and the heme molecule contains iron. And that means that 4 oxygen molecules can be carried by a hemoglobin molecule at one time. Hemoglobin also can carry transport a certain amount of carbon dioxide through the blood as well. Number 7, how would the hematocrit change after a significant blood loss? Well, the hematocrit is the percentage of red blood cells, so it's going to decrease. And number 8, in what way would a disease that causes liver damage affect the level of bilirubin in the blood? What you want to say is that it would, hold on a minute. I apologize. I wanted to look that one up to make sure I was thinking about it in the right way. So we know that bilirubin is formed in the liver. It's one of the breakdown components of hemoglobin. And so if the liver is damaged, it's going to leak into the blood, and so that would increase the level of bilirubin in the blood. Let's see. Keith develops a blockage in his renal arteries. Renal arteries are the arteries that supply the kidneys, and that restricts blood flow to his kidneys. What effect will this have on his hematocrit? Well, the kidneys are going to detect hypoxia, and then they're going to produce EPO or release EPO, and that's going to produce more red blood cells. So it will raise it eventually. Okay. All right, let's move on to the blood types and the ABO blood types and the RH system. This is how we determine if we're type A positive or O negative or whatever blood type. So blood types are based on the antigen-antibody responses. Antigens are substances that can trigger an immune response. They're usually located on the surface of cells, the surfaces of plasma membranes of your cells. And if they're located on the surface of your body cells, they're considered normal, not foreign, and they won't trigger an immune response. But foreign antigens will. Like if they were to be antigens found on someone else's blood cells that were different from your surface antigens, they would trigger an immune response in your body. So the three major antigens are A and B, and then RH, which is sometimes referred to as D. These are the most important ones in determining blood type. And I'm just going to move, here we go. So in blood type A, if you look at this chart here, helps you understand blood types the best, I think. In blood type A, this shows you what you find on the red blood cells, and then it shows you what antibodies are found in the plasma of that person's blood. So a person with type A has surface antigen A on their red blood cells, and surface antigen A is shown here as a round red molecule. In the plasma, blood type A will have type B antibodies. They're called anti-B antibodies. So they're going to attack B antigens if you were to accidentally get the wrong transfusion with type B blood or type AB blood. Any type of blood that has B antigens on the red blood cells. Now, if a person is type B, their red blood cells will contain surface antigen B on the surface of the red blood cells, and their plasma would contain anti-A antibodies. If a person is type AB, you will see both the A antigens and the B antigens on the surface of the red blood cell, and then you wouldn't have any antibodies, anti-A nor anti-B, in the plasma. If they're type O, they aren't going to have either of the A or B surface antigens, and you will have in their blood plasma, they're going to have both the anti-A antibodies and the anti-B antibodies. So what's going to happen if you get the wrong blood type transfused? You're going to have a clotting reaction. So let's say that so right here what we see on these red blood cells are type B antigens. So this is type B blood. And in that person's blood plasma you're going to have oh, I'm sorry, they're not showing it like that. Okay, so let me explain this chart better. So what we have is the type B blood mixing with someone who has anti-B antibodies in their plasma. Okay, so that could be someone who's type A or type O. So anti-B antibodies in the plasma are going to be somebody who's type A or somebody who's type O, where it says here opposing antibodies. And when they mix, the antibodies are designed so that they can attach to those antigens, and they will attach and they will cause clumping. They will cause clotting, and that will eventually cause the red blood cells to burst, and that's called hemolysis. So, and that can lead to death. Okay. So we've talked about A and B, so let's compare that to Rh. Anti-A or anti-B antibodies spontaneously develop during the first 6 months of life. No exposure to foreign antigens is needed. So, but with Rh, the anti-Rh antibodies in an Rh negative person don't develop unless the individual is exposed to Rh positive blood. So what happens here is so the problem that we can wind up with, the slides are not real clear about this, but I can explain it to you. The problem we can wind up with is that if you have a baby that's Rh negative and the mother is Rh positive, during childbirth, the baby's blood can be exposed to the mother's blood, and the baby can start to build up anti-Rh antibodies. But it wouldn't do that unless it was exposed to Rh positive blood. So if the mother was Rh negative, it wouldn't matter. But if she's Rh positive and the baby's Rh negative, it can be dangerous, not for that first baby, but if she were to have another Rh negative baby, then those anti-Rh antibodies could, they can actually cross the between the mother and the baby's blood, and they could attack the baby's blood. Okay, they could attack the baby's blood. So there could be a cross reaction. And so what they do is they give the mother RhoGAM sometimes they give it during the same, whenever they deliver the first baby. But anyway, it's more dangerous for the second baby, so they make sure she gets the RhoGAM shot before, the second baby. Let's see. So this is showing blood type testing for, we didn't talk about Rh, but basically you get 3 drops of blood and you mix the blood with anti-A antibodies, anti-B antibodies, and anti-Rh antibodies. And anywhere there's clumping, that means that you have that antigen. It's because the antibodies are going to clump with the antigen that matches the antibody. All right, so up here at the top, we have clumping in anti-A and anti-Rh. So that means we have blood type A positive, because if you have the Rh antigen, then you're positive. If you don't have it, you're negative. All right, in the anti-A in row B, or in the second row, we have no clumping, but we have clumping in the anti-B and the anti-Rh, so that would be B positive. Clumping in all 3 is AB positive, and no clumping is O negative. So this doesn't give you all the results, but it gives you enough results so you should be able to understand how a blood type test works. The universal donor for blood transfusions is type O negative, because there's no antigens, there's no A and B antigens or Rh antigens, so they would be able to donate to anyone, any type of blood type, because you're not going to be introducing any foreign antigens into the recipient. Then the universal recipients are AB. It would actually be AB positive because that person has all the antigens that you can have, A, B, and Rh, and so they can receive from anyone. All right, number 10, which blood type can be safely transfused into a person with type AB blood? So they can receive from type A, type B, type O, or type AB, and so they're the universal recipient. Number 11, why can't a person with type A blood safely receive from a person with type B blood? Because the person with type A blood is going to have anti-B antibodies in their plasma that will attack and cause a cross-match or a clotting reaction whenever they receive blood from the type B. All right, now this is going to show you the different white blood cells or leukocytes. They can either be granulocytes, meaning they have granules in them, or they can be agranulocytes, in which